Our third example on proving trig identities is another textbook question taken from Additional Mathematics 8th edition by Te Keng Seng and Lo Cheng Yi, published by Xingli Publishers, exercise 6G, part L. We are required to prove that 1 minus 2 cos squared a divided by sine a cos a is equivalent to tan a minus cot a. Now when I look at the left hand side, I am seeing a single fraction. Numerator 1 minus 2 cos squared a and the denominator sine a cos a. So it's a single fraction. But what I want to end up with on the right hand side is actually two separate quantities, tan a and cot a, and they are separated by a minus sign. This means that I need to split this single fraction into two separate fractions separated by a minus sign, because on the right we have tan a minus cot a. So what I'm going to end up with when I work down the left side, I'm going to have a common denominator, two terms on top separated by a minus sign. That would allow me to split this single fraction into two separate fractions, because both terms in the numerator have a common denominator. Now tan a is really sine a over cos a, and I'm seeing a cos a term in the denominator. I have sine a cos a, and cot a is cos a over sine a, so it's cosine a over sine a, and I'm also seeing a sine a term in the denominator. So I'm seeing the sine a and the cosine a that I need. So that is a good sign. The numerator jumps out at me, 1 minus 2 cos squared a. I'm immediately thinking of the double angle formula cos 2a. Cos 2a, one of the three versions that we learned was 2 cos squared a minus 1. Here I have plus 1 minus 2 cos squared a. So it's the same thing except that the signs are reversed. Again, cosine of 2a is 2 cos squared a minus 1. So 1 minus 2 cos squared a is actually negative cos 2a. So we need to know our double angle formulae, compound angle formulae, and our trig identities inside out to be able to have recognized that. So this is taking the left hand side, 1 minus 2 cos squared a over sine a cos a is equal to minus cosine of 2a on sine a cos a. Now I know that cos 2a, there are two other versions, one of which is going to prove itself very useful. Cos 2a, apart from being 2 cos squared a minus 1, it's also equal to cos squared a minus sine squared a. I'm going to put that in here. And it should be immediately apparent how that is going to help us to get even closer to the right hand side. When I expand on top, that's minus cos squared a plus sine squared a, or sine squared a minus cos squared a, when I multiply the top by minus 1. And now we see how we can split this single fraction. So I have sine squared A over sine A cos A minus cos squared A over sine A cos A. Good, now this sine A will cancel with one of these, so sine squared A on top becomes sine A. So this is sine A over cos A. That's tan A minus, and again this cos A in the denominator will cancel with one of the cos A's on top. So cos squared A becomes cos A, and cos A over sine A is cot A. And there I have obtained what I needed to obtain on the right hand side, tan A minus cot A. So 1 minus 2 cos squared A on sine A cos A is equivalent to tan A minus cot A. And what was important there was that I needed to know my double angle formulae for cos 2A in particular. So again, I cannot overemphasize how critical it is in proving trig identities for us to know our trig identities and also the double angle formulae and compound angle formulae. And for advanced level pure math students, you also need to know your half angle formulae.